do slaves need to survive?
Nothing.
Not to be fucked with. That's what they need.
Nope.
That's what makes us powerful. Because we don't need nobody. You know what I'm saying?
Nope.
But everybody needs the slave.
But Mr. A, it's that time. I'm about to do my homework and get on and get this party started. So, yeah.
Well, go ahead and take care of your dinner. I'll talk with you later.
I'll talk with you later. Yeah.
All right. Okay. In a minute.
Let's do this. It's time to do homework. Okay. And high if I haven't already set it. My chat. I'm taking programming like Fullsail, and I'm doing my homework live, so you guys can watch me be a functional adult.
Sure. They're all. Number one. To work, but this one took us 3 time to come back up, but we will get back at slides. I think there are only a few more for this one. I'm not sure. It'll be around 6 when I'll be actually be able to see the recording. If it did not get recorded, I will upload a archived version from last month. All right, back out of signature. Again, it's going to be basically this entire line. We're ignoring static. We have our return type, our identifier, and our parameter list. Something that we can do specifically with methods, not variables, is called overloading. In C++, an overloaded method is a method that shares the same identifier but has a different list of parameters, return type, or both. So we have 2 methods right here called int sum, and the difference here is the parameter list. Our first sum has 2 int parameters, int for 1 and for 2, and our overloaded sum is going to be 3 parameters, int number 1, int for 2, and int for 3. Basically, it's allowing us to provide additional functionality to a method that shares a name. So basically, we're achieving the same goal effectively with the method, but we're adding in different things to do. So if we wanted to, we could continue this on and add 4 numbers together, 5 numbers together, or instead of working with strictly whole numbers, we can change the return type of this to be double or float, and then we can actually start working with those types as well. So keywords for today, basically saw public almost every slide in this lecture. Access modifier keyword for the purpose of the course will allow a member variable or method to be accessible within a class other than the one in which it's defined. Okay. And then private, which is basically if you're on a Windows machine or even I think Mac as well, everything is defaulted to private. So you don't necessarily need to utilize this keyword a whole lot, but just know that it exists. It's an access modifier for the purpose of the course will prevent a member variable or method to be accessible within a class other than the one it is defined. Class members will be set to private by default if no access is specified. And then void. So void is used as a return data type when a method or function does not require any data to be returned. A lot of the time, you're going to see me write a method called line. It's going to do something similar to this. You're also going to see me write another method that is essentially this in of itself. It's for formatting purposes for output when we're doing the live demo. So void return type, no return inside of the script. Static, we don't care about. Return is going to be used to denote the beginning of a return statement preceding any value or reference to be returned. So int return type, an int must be returned with the return line. And then again, using a single return statement within any function or method is best practice. You can have multiple returns inside of your methods. However, it is not best practice and it will give you a 10% deduction. And then kind of what I was describing earlier is any code that is under a return, you'll get the green squiggle, not the red. It's going to be a warning, and it's going to say unreachable code detected. You can also think of a return statement as the exit of the method or function in itself. So once a return happens, nothing under it will happen. We have the parentheses. It's going to denote the start and end of a parameter list for a method or function when used within the head or signature. They are also required when calling a function whether or not it has any parameters. And then the curly.
My daughter is texting me. I was supposed to be hanging out with her today for Halloween, but I reprioritized homework. map in the app. The most beautiful map in gaming.
Growing up, I had near unlimited access to the internet. I didn't spend all of my time on it, but I did spend a lot of my time watching YouTube videos. Through these videos, I heard tales from older gamers of playing an innocent kid's game only for it to suddenly take a dark turn. The bottom of the well and the shadow temple of Ocarina of Time, the melancholic lavender town of Pokemon Red and Green, the Hell Valley Sky Tree. Eventually, I too would experience something like that. First while playing Warriors: The Road to Immortality, twice playing Pokemon Sun and Moon, and once played Minecraft when I discovered Disc 11. But nothing stuck with me as much as the map in Wolf West, the video game where you play as a wolf. In this video, I'm going to show you why I think this map deserves
Alex. Hey, I'm streaming, but I wanted to ask you because the video actually came out really, really good. Do you still have a passion for wanting to do video editing?
Yeah.
Okay, so I'm about to be really, 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 really sad. What do you know about computers?
Not a lot.
You know I love you, right?
Yeah.
You know I love you a lot, right?
Yeah.
I'm gonna send you a picture. I'm going to give this to you. Because our video is actually really impressive. I've been debating on if I wanted to keep this, or if I wanted to give it to you. And I know I should keep it, but I'm gonna let you have it.
What kind of computer is it? Like,
I'm gonna send you a picture now. It's the best computer. It is the best computer.
Is it able to run DaVinci Resolve?
It's got an i9 processor. And it's running it's running NVIDIA GeForce RTX. It is the best computer. It's actually better than the one I'm using. So you know how normally kids get the hand-me-downs?
Yeah.
I'm actually going to give you the better computer. So,
Okay.
but
Sure.
but
Give it a try.
there is only one condition. Only one condition. I need a computer to do my homework. So if the computer I'm using clunks out on me, I might come and get it back. That's the only condition. It's yours to have forever. But if I can't, huh?
Are you cool with me trying to put Linux on it?
I would recommend that you don't. But
Okay.
if you want to, you can. Because this computer is the best computer. Like, it does everything. It's a gaming computer. It runs. They gave me this computer to do programming in Fullsail. It is the.
Is it Windows 11 or Windows 10?
It's probably Windows 11. I haven't even turned it on yet, so we'll have to hook up. Maybe sometime next week once I get caught up on school, we'll hook up.
I don't want to have a Windows 11 computer, to be honest.
I mean, if you want to put Linux on it, you can, but you're gonna destroy the computer.
Alright, then I think I'd rather stick with trying to build my own computer.
Okay.
So I really appreciate the offer, though.
No worries. If you need, once I get financially stable, if you need extra cash to help you build your own, then I could probably try to do that. But the video is really, really impressive. I actually, I really like it. Even from like just the little intro, the audio and the pacing, everything was really good. So it made me really proud. So, I'll have to finish it later because I'm in the middle of homework. But yeah, I was like, you know what? She needs this computer. I was like, because I've been really debating like for the last week, which I've been being selfish. Like, do I want to keep it? I need it. I might need it. I don't know if I'm gonna need it. I can't afford anything like this. It's a really good backup computer. But I know my daughter wants to do stuff like this too, so maybe she wants it. I don't know. So, yeah. But I'll send you the stats, and then you can tell me if you wanna I'll send you pictures of the actual specs so you can do the research on your own.
Okay.
And look at the hardware and see if you want to uninstall Windows and install Linux on it. I don't recommend it though. I understand why you want to leave the Windows landscape. I really do. But sometimes you have to make sacrifices to do things that you love, and it'd be nice to be able to just do what you're trying to do while you get set up to do what you want to do. So just think about that. Sometimes I know the energy. I was the same way, and I was like, you know what? This is not working. This is not working for me. I want to do the things I want to do, and I can't do the things I want to do because I'm creating extra adversities that I don't actually need in the process. So just think about it. I love you. I apologize for standing you up on Halloween, but I gotta do homework.
Okay.
I wanna build epic video games so you can be proud of me.
Alright.
So, well, yeah, I'll talk with you later.
Okay. Bye. Happy Halloween.
Happy Halloween. I love you too. Bye. Okay, let's get back to school.
Brackets are going to be used to identify the body, block, or scope of the method function.
Just so y'all can see
So for that question
what she
online,
turned down.
I will show an example of more.
She turned this down.
There is a specific test in Lab 3 where you have to work with 3 string parameters with a string return type.
The
that you can hit.
greatest computer
Something like that.
on the market. The best laptop
Yes, sir.
on the market. She turned it down.
So in this language, the head or signature doesn't get semicolon. And depending on what you're doing, more often than not, like 95% of the time, you don't need to put a semicolon at the end. Scope brace of it. Sometimes you'll see it, like the int main. Sometimes we'll get one when you create a new project. Sometimes it's there, sometimes it's not. Okay. So that's it for the slides. Before we jump into the actual code demo, do we have any questions that we saw on the slide?
Took my pizza cutter. Man. So lame.
All right. If no questions, we're just gonna jump into it. I encourage you all to go along with me. You do not need to, but practice is the best teacher. More often than not, when it comes to programming. So, the only thing that I have changed prior to what I just did is the comments. The other thing that I'm going to add really quick is at the top, we're going to do an include, if I can type correctly, for string. Okay, so starting out, we have already used a handful of methods if you've watched so far. We're going to start there. We're going to start with calling a method, just in case anyone has not touched Lab 2 yet. We're going to use string to int or stoi. It's for Lab 3. Yeah. everything leads into one another, and when I do a lot of methods, I backtrack just to do review a lot. So today is all about creating methods from test 6 to test 10. You'll create a method, and then you'll actually call that method as part of the actual test method. So like test 6, for example, in part 1, you create a string method called concat, and then in the actual test 6 method, you have to call that the concat. So right here, I create a string called number. We initialize it to the value of 3. And the purpose of that is we have to have a value to utilize string to end. And then we create an int variable called converted number, and we assign it the call of string to int, and we pass in number. Question for at the top is the included for string. Excuse me.
Do we need to include any of those on the labs?
No, so you do not need to add any includes unless an instruction specifically tells you to. And I don't believe any of the labs are currently doing that. They should already have. All right, you're also going to see me write a bunch of notes. I kind of explain my process as well. Like I said before, all of this does end up on Discord for you all to download as well. So if you don't capture everything as I type it out, don't worry about losing it. You will have access to it. So notes being on the above line, the int converted number equals string to int, passing in number as a argument. Is on the above line, we initialize an int called converted number to the method called string to int. String to int is part of the string library. We include it at the top. The parentheses next to string to int is required when we call a method. And since string to int has a parameter in its definition, we must provide a string value. We can look at its definition, and you can do this for any method by right-clicking in peek definition. However, if you do this on code that you have not written, at least at this stage, experience, it may look alien. But we'll see an actual example of that later on with the method that we write. Then string to int will force the conversion of the value of number, our string that we have. And should it actually convert, it will return the numeric version of that value. And since we're initializing the value of converted number to this call, the return value will be assigned to converted number. So number has a value of string literal 3. string to int is going to force the conversion of that, since it is a numeric string effectively. It's something that it's going to store the converted value of that string literal 3 to an int 3 into converted number. We can see that by placing a breakpoint right there and running. So with breakpoint on there, we can see that it's running. We have the little yellow arrow pointing to the line. We can see the value of all of our variables. So in this case, we only have 2. We have a number. This line has not run yet because I have not stepped into it. So we're going to see some garbage default value that's given to the variable. One of two things is going to happen here because I don't have anything under, this converted number line. It might just self-terminate the program because there's nothing else. However, the other option is we may end up seeing the actual value converted, which we do. So something that you probably went over on Wednesday is the use of breakpoints, autos, and locals window. When you're working with stuff like this, it's kind of hard to see like the actual conversion happen. But when you use debugging, the breakpoints and the actual step into, we can see that number has the string literal value of 3. We can see its type right here is string. Converted number is an int, and we can see that it lacks the quotes. It's also assigned to an int variable, so it is. Next, we are going to write a void method. So in the live demos, your methods are going to be outside of the main, but inside of your labs, they are going to be where specified. So above the main, we're going to write a method. I'm going to put a section for notes there. We're going to say void. I'm going to call it line. You can call it whatever you want. Its entire purpose is to output as many dashes, asterisks, equal signs as you want. We are formatting output this way. So before writing our notes, we can see what that actually does by calling that method either right here or right here, doesn't really matter. Something else you're going to see me do a lot, I have a habit of doing this, is in most languages like C# or Visual Basic, the language does a really good job of updating itself as you write. Think of it as like an autosave feature in a game. C++ does a horrible job of that. So sometimes if you're writing a lot or even a little, and you go to run it and you don't see the stuff that you just wrote, best bet is to go to the build option at the very top, rebuild, and run. That'll more often not solve the issue of you not seeing what you just wrote. I do it very often. You're going to see me do it a lot.
Question on that, for labs, I've tried to rebuild, we're getting all kinds of breaks, and it won't rebuild. Why is that?
Typically going to be an error, but I would have to see the specific output. So if you want to send me some direct messages with screenshots, I can work out with that.
Thanks.
Yep. So it does nothing special, just outputting. We write this so we can, I write this method so we can separate different outputs from all the demos that we do. Because the more sections of code or more methods that we run, it'll basically end up looking like a giant ball of text, and it's just easier for me to read and separate it visually that way. Now, what I also like to do with methods is put like a little annotation above it. So you don't need to verbatim do this for every method, but for the live demos, I like to explain the entirety of the process. So you'll see me do this for a lot of the methods, not all of them, but most. Next, we're going to write another method. It's going to be basically the last one that we saw on the slides. It's going to be that show dialog. I'm going to call it message. So we're going to do void message. So here, similar to what we saw on the slide pretty briefly, we have a void method, so no return. Its identifier is method. It has a single should be particular whatever we so in this case, instead of writing C out every time that I want to and it's going to be formatted to the parameter list is going to be the string words, and all this thing does is it's going to output a line, output whatever is inside of the parameter, and then output another line. So to utilize that, I'm going to comment out our very first C out, and I'm going to say message. Welcome to day 3. Methods. And then we're going to add whatever we want at the end just to see that it's different. So we can see that the actual output is coming from this method call. So we can see the output from that message method, and then we see the line from down here. So that's why we see the double line right here. I have main, I have message, and I have line. Yep, I called line twice. Yep, tell me when to stop. All right. Yep, I called line twice. Yep. Tell me when to stop. Alright. Alright. Next, we're going to do various different versions of sum. And then we're going to start seeing methods that utilize other types besides void int and string. Alright, so here we have our int sum from the slides, where we have two parameters, int number 1 and number 2, and we're shorthanding everything that we saw in the slides to return number 1 plus number 2. So before we call that, in the main, I'm going to put a note on that. And if the method is simple enough, we can utilize something like this where we don't need to make another variable, we don't need to assign that variable, we can just simply return an equation. That equation is going to run, and then the return will happen. So it's going to calculate whatever that equation happens to be. In this case, number 1 plus number 2. And it's going to return whatever that value happens to be to the method call. So if we go back down into the main after writing sum out, I'm going to go under our call for line, and I'm going to create an int called captured return. And we're going to equal that to sum, and then do whatever values you want. So I did 2 and 2. And while I'm thinking about it, because I showed peak on something that we did not make, if I show peak on something we did, it's just going to create that little window, and we can see the code for that method and scroll a little bit. This is particularly useful when your projects eventually become hundreds or thousands of lines. So you're not always like scrolling back and forth. You can just peek the definition of the method and see it right there. Also, as we were writing method calls, you can highlight over it, and you're going to see any annotation that we put directly above it. So the multi-line comment that I put above the 3 methods so far, specifically for this one, it shows us the return type, the identifier, the parameter list, and the goal of the method, along with the signature or head of the method, the int sum, and then int number 1 and number 2. particularly useful if you're not 100% sure of what method requires. You can just hover over it and you'll see all the requirements and potentially notes that are written for the method. And then I'm going to call message and toString. So this is probably going to be one of the first times that you've seen change method calls. We call message, and because message has a string parameter, it requires a string value. Captured return is an int. So we must convert that to a string for this to not error. If I get rid of the toString, we will see no suitable constructor exists to convert from int to the rest of that. So contextually relevant to us, it's pretty garbage output. However, with the context of what we're doing, we know that message requires a string, captured return as int, we must make captured return have a string value or convert it to a string value. And we can do that with toString. And we can see the output there before. Now, if we wanted to further format that line to have some relevance when we actually have some more output on the screen, we can actually concatenate inside of the argument list or the what we pass in. So you can put whatever relevant verbiage that you want. I'm going to do captured return to string, and then I concatenate in using the plus operator or the concatenation operator and the toString value of captured return. So now when I rebuild this and run it, we can see that. That specifically is within these parentheses. So specifically, that call exists inside of the scope for main. But when I call that that method, so message right here, and I have these values right here, we're passing that together. It's getting concatenated in as a singular string. And when you call a method, what happens is normally when you execute a program, so like if we think back to lab 1 where it's hello Fullsail, you set up a string name, a string age, you prompt them for their name, you prompt them for their age. It's happening in a top-down fashion. So it's like hello Fullsail. That's the first thing that's usually in lab 1. And then you prompt the user for their name, you set up that variable. It's all happening sequentially. So whenever we call a method, that interrupts that sequential or top-down flow. So in this case, we're calling message, and we're inside of main. It jumps down or jumps up to the definition of message. We go inside of that scope specifically. It does everything inside of that scope. First thing being line. It jumps to line, does everything inside of that, goes back to wherever that method was called. So we're back in message. We output with a cout, and we call line again, so it jumps back up to line. We're in line scope. Does everything inside of line. Once we reach the end scope brace, it goes back to wherever that method is called. So right here. That's the last thing inside of message. We go to the end scope brace of message, which then will pop back to wherever we called message. So line 100 something in main. Before we continue on with more sum methods, do we have any questions on what we've seen so far? Yep. All right. So continuing on, because I have not seen any questions from online, haven't heard any yet. We're going to write another sum method. So I write a little annotation first, basically the same information, but with the overloaded sum method at the top and the extra parameter. So we're going to do int sum, int number 1, int number 2, and int number 3. So the notice inside of the actual method itself is we're going to see the execution of the method the long way. This is going to ensure that you never have to write multiple returns. So to start that, we're going to have to pay attention to the return type of the method. After we identify the return type, int, we're going to create a variable of the same type inside of the scope of the method. You'll hear me call this variable, it doesn't matter what type it is, because we're going to be working with methods of different types, as a placeholder variable. It doesn't need to be called placeholder, it can be called result, it can be called whatever you want, as long as it's relevant to whatever you're doing. Next, we can assign that variable something. We can also do that on the same line should we want. It'll just reduce the line count by 1. So it seems simple enough. We just create a variable inside of the scope of the method. We assign that variable some value, basically whatever we end up doing, and we're going to return that variable. On Monday, this is going to become much, much more prevalent because you're going to be working with decision-making code, if statements, switch statements. Go over that on Monday, but you can basically think of the basic example that we give is you walk into a room, the lights are on. You want the lights on or off. If you want them on, switch. So it would run the code that would turn the lights on. If you don't want the lights on, don't do anything. There's going to be, in that lab specifically, opportunities for you to have as many returns as you want. It's doable. The syntax is correct. It's not going to error out. However, it is best practice to have a singular return. So I would make notes, screen cap, picture, whatever you want, keep it in your head when you get to day 4 and beyond. This is what you're going to be wanting to do. And also for this specific example of the overloaded, this is going to be something that we see in lab 3, test 10. So we're also going to see multiple other overloading examples. This is going to become much, much more prevalent because it doesn't need to be called placeholder. It can be called result. It can be called whatever you want as long as it's relevant to whatever you're doing. Next, we can assign that variable something. We can also do that on the same line should we want. It'll just reduce the line count by 1. So it seems simple enough. We did create a variable inside of the scope of the method. We assign that variable some value, with basically whatever we'll end up doing, and we're going to return that variable. On Monday, this is going to become much, much more prevalent because you're going to be working with decision-making code, if statements, switch statements. Go over that on Monday, but you can basically think of the basic example that we give is you walk into a room, the lights are on. Do you want the lights on or off? If you want them on, flip the switch. So it would run the code that would turn the lights on. If you don't want the lights on, don't do anything. There's going to be, in that lab specifically, specifically opportunities for you to have as many returns as you want. It's doable. The syntax is correct. It's not going to error out. However, it is best practice to have a singular return. So I would make notes, screen cap, picture, whatever you want. Keep it in your head when you get to day 4 and beyond. This is what you're going to be wanting to do. And also for this specific example of the overloaded, this is going to be something that we see in lab 3, test 10. So we're also going to see multiple other overloading examples. But for now, we're going to call this, we have int sum with 2 parameters and then int sum with 3 parameters. So we already have a int made inside of the main, captured return, we're going to continue to use that. So we're going to say captured return equals sum. Now, if I leave this alone, we have the IntelliSense open. It's going to try and like predict whatever we want. We can see the method that we wrote, the sum. I'm going to type in a parentheses. As we were typing this method, when you're working with overloaded methods, you can see all of the definitions as a quote-unquote drop-down box. Right here is our initial one where we have the 2 parameters. If I click the arrow either way, we're going to see the other one. So in this case, we have int sum with 3 parameters. You don't need to select the version of the method that you're running this way. The compiler is going to automatically predict what you want as you type it. And we're going to see examples of that here in a minute, because right now, if I type in 2 values, it's obviously going to pick the version of sum that has 2 parameters. If I type in 3, it's going to obviously pick the one that has 3. But when I error. Let's see the other one. So in this case, we have int sum with 3 parameters. You don't need to select the version of the method that you're running this way. The compiler is going to automatically predict what you want as you type it. And we're going to see examples of that here in a minute, because right now, if I type in 2 values, it's obviously going to pick the version of sum that has 2 parameters. If I type in 3, it's going to obviously pick the one that has 3. But when I change the type of the parameters, that's when we're going to see it like actually pick. Now this becomes 7 and 12. So we're going to see captured return to string 12 as one of the final outputs after we run this. Right there. Now we're going to, instead of use int values, we're going to mix in double float or make them all double or float. It doesn't really matter what we do in this case. So I'm going to do one that has 2 parameters, 1 int parameter, 1 double parameter. If I left this as 2 ints, when we go to run the project, it is going to give us an error because we already have a version of sum with 2 ints. So specifically, you do have to change the type if you leave the number of parameters alone. So again, 2 parameters here, scroll up, 2 parameters here. These are double int. This one that we're about to write is int double. That was a really bad way of saying that. We have 2 ints for this one, and then we have an int and a double for our third sum method. So we're going to say int sum, int number 1, double number 2.
How do you,
We're going to create an int result like we do in our other overloaded example.
how do you add a?
And then instead of making a 3 lines this time, we're going to just do the assignment on the same line. So we're going to initialize result to number 1 plus number 2, and then return result. So now, I type in
It's
sum.
funny how we're trying to
We
make
can
it
see
work.
that there are 3 versions now.
Confuse everything.
So if I type in a value, and I type in another value, right here specifically, it's choosing int and double, but it also could be our original, perfectly fine. But the moment that I type in some value that's not a whole number, it will automatically force this to be the version of sum that has int and double as its parameters.
I see. All of that talk about not doing things automatically, and then the very first thing you do is something automatically.
And then also to note, because sum has an int return type, and we're working with a not whole number as part of the parameter list, the 2.4, this should come out to be 3.4 because 1 and 2.4, obviously 3.4. However, the return type is int, so it is going to truncate the decimal place. It's not going to round either way, it's just going to chop it off. So when we run this, we're going to see 3.
Because it's some method has an integer return type, it is going to truncate the decimal place. I guess I could just Google it normal. One of the paragraphs. Sure, sure, simple.
Yeah, not a problem. I will slow down a little bit. And I'll leave it on screen for you. If there's anywhere that you want me to scroll to so you can copy it out, just let me know and I'll do it. All right, so now we're going to change the type of sum. So we're going to write another overloaded sum. because the type on this one is double, we don't create an int variable, we create a double variable because we want our placeholder to match the type of the method. And we simply return it. However, we are getting an error, and that is because in this language, or at least this version of C++, we cannot simply overload by just changing the type. So we would also have to change the parameter list. We can do that by either changing this to double, and it's perfectly fine because we do not have a version of sum that has two parameters that are double, or we can just simply add another parameter, which is what I'm going to end up doing.
Return type is double. Return the sum of all parameters.
So after those notes, we're going to scroll back down to the main, and we are going to call this version of sum. So now we have two versions of sum that should have three parameters, one with an int type and then three int parameters, and then one with a double type and one int parameter with two double parameters following up. So inside the main, this time we're working with a double type sum, so we're going to create a double, call it whatever we want. When I say holds double return, and then we're going to call sum. Type in that parenthesis, we now see four versions of sum. Type in one, and we're currently seeing the 3 ints version. And it just knows that we're, like, if we hover over this now, we're going to see number 1 as an int, and then number 2, number 3 as doubles. I'm going to highlight this line once more, paste it in, change the relevant things around. And now we're going to see the 5.7, I think. Yeah, 5.7. Without further string formatting, which we really don't need to worry about right now, you may see the extra zeros. The number of the extra zeros that you see is going to end up depending on if you use float or double. I can't remember which one is more, which one's less. But you don't really have to worry about it. I will say, because I do see it a lot in some of the labs when you're returning numeric types, pay attention to the return type. So kind of like what we saw with one of these thumb calls, this one specifically where it's 1 and 2.4 and it truncated the decimal place. If you're working with ints, but the return type is like float or double, and the value, the expected result is not a whole number, so it has a decimal place, that decimal place gets truncated, the answer that you get is ultimately not going to pass for that version of the text. So you're going to have to pay attention to the return types and the types that you're working with. Just keep that in mind. And then online question, how is it possible to have double on one side? What do you mean? Yeah. The curly brace. So you're talking about up here? More specifically, right here.
Oh, integer double double.
where we were.
It kind of makes sense. It's really cool that it kind of makes sense. I kind of feel like.
So, if you're referring to this right here, this right here is not the same as the double return, but when we're utilizing toString is looking specifically for something that's not a string, and it's going to convert whatever is not a string to a string. So it's not like I'm using the double keyword specifically, I'm just using a double variable. And then the reason this closes with a double parenthesis is we're working with chained methods. So I have message here, which has its own set of parentheses, the opening right here and the closing right here. And inside of that set of parentheses, I have the toString method here that has its own set of parentheses. So the opening here and the closing here. All right. Go ahead and take a 10-minute break. Be back at 2:46. I'm going to pause the recording so we don't bloat it up, and then I will get all the questions written up at the top as a note, and I'll be here to answer anything that gets asked or I see online. We're now going to look at a string method. And we're also going to look at concatenation. So before we do that, before we do the actual method, we're going to do look at an example with concatenation. All right, so we set up two strings, one identified as hello, one identified as world, and they have their respective word as the value for the variable. So we have one with hello, one with world, and then down below with greeting, we concatenate hello and world together. Next, we're going to do a bit of output so we can see all of them together, or all of them separate and then combined. And then we can go through and see specific examples that will help understand test 6. So we have an output for both the hello variable, the world variable, and then greeting. So this line is going to say hello colon hello. This line is going to say world colon world. And this is going to say greeting colon and then hello world with no spacing. So the compiler is not going to be smart enough to add in any grammar, punctuation. We're going to have to do that manually ourselves. So specifically test 6, you have 3 strings that you're going to concatenate together. And there's going to be a space between each variable effectively, because each variable or parameter is going to have part of the phrase when concatenated together is going to be a complete question. So you're going to have to add in multiple spaces and the question mark yourself.
I'm gonna do it.
Now right here, we have, we're reassigning the greeting variable to hello plus an empty space plus world plus an exclamation point. We rebuild after the output, and we can see the difference between actually adding in the punctuation and not. This is going to be helpful for test 6 specifically. Now, if we wanted to make a string method that has 3 string parameters, what do I want to call it? It's called strings. So we have a string sentence with 3 string parameters. We have our placeholder variable, string result, they match type. We assign result, concatenated in word 1, word 2, word 3. With the note that this is very close to what you need for test 6 part 1. The rest is going to be up to y'all. And then we return the result. So,
Yeah.
now right here, we have, we're reassigning the greeting variable to hello plus an empty space plus world plus an exclamation point. We rebuild after the output, and we can see the difference between actually adding in the punctuation and not. This is going to be helpful for test 6 specifically. Now, if we wanted to make a string method that has 3 string parameters, what do I want to call it? It's called yes.
Two, three. Result equals word 1 plus word 2 plus word 3. I think the equal sign on all that is what's.
So we have a string sentence with 3 string parameters. We have our placeholder variable, string result, they match types. We assign result, concatenated in word 1, word 2, word 3. With the note that this is very close to what you need for test 6 part 1. The rest is going to be up to y'all. And then we return the result. So,
Greeting equals syntax 1, 2, message. Greeting is already a string.
we message out greeting. The reason we don't need to use toString here is greeting is already a string. And we can see the concatenated 1, 2, 3 here. With our 3 values of 1, 2, and 3. Again, it's not going to automatically add in any punctuation, grammar, spacing. You're going to have to do that manually. So combine what I have inside of sentence with here, and it'll get you on the right path.
Greetings equals sentence. Message greeting.
And we can see an example with hello world as well with the exclamation point. Now, we've talked about pretty much everything about methods. We've made int, double, and string methods. We could go through and make others. But what we haven't actually talked about and what we don't have in notes is going to be about each individual key piece. So the return type, the identifier, parameters. So I'm going to find where I put my notes section somewhere here. And we're going to talk, basically put all of that in notes. Change that to 4. So when we write a method, like what we've done so far and what we've seen in the slides, it's going to have multiple parts for the signature or head of the method. The return type, the identifier, the parameter list, and the scope.
The scope is what I've been missing. That's what's been fucking driving me goddamn crazy is the scope. That's what's missing. The scope is what's been missing. the identifier, the return type, the parameter list, and the scope. Fucking scope. That's what it's been. All this time, that's what's been missing. The scope. That's the one damn word that I've been struggling with. That's it right there, the scope. I'm going to bed. So I've been trying to understand a method. I get the function, I get the programming, I get the operations. I kind of understand how to structure the different parts of the code. I still struggle a little bit. I've only been doing this for like 2 weeks. But when it came to the method, I know that a method is several different pieces of functions together. And I know that the main role of a method is to be able to write centralized code that you can use over and over again, right? Like it's like a prefab, so to speak. And then since you have this prefab, you can use it anywhere else you need that same logic in your code for other things. You can use that piece of that prefab later to help you do something. It's like this does A, and you need A plus B to give you C, or you need A plus D to give you E, or A plus E to give you F. Once you define A, you can always use A wherever you need that part of A anywhere else. That's basically what the method is. I knew the return type was the very beginning, and I was associating return type with the return because there's always like return and then some variable with the semicolon behind it. I understood after the return type was I forget what it's called now. The function, I believe. The function type. And then after those two, and I could be wrong, but then after those two in the parentheses was the parameter type and the parameter name, or the parameter type and the parameter list. Two variables with the parameters. And then underneath that is where the return type would go. The return and then the operation. Above the return is the return operation. I know that's probably not right, but it's just what I've been struggling with is the scope. The scope is what it has. That's what has been eluding me with understanding the method. And now that I have that one piece, I think I'm good. I think I'm going to bed so I can get up and have a fresh brain to finish going through the rest of this. I'll continue to stream. I'm going to continue to keep doing it this way. So, yeah. As always, when there's one I was saying, I'll give you guys messages. It's just 10:30. It's between 10:31. So, it's time to go to sleep. I've been having really long days.